I'm Matt Forrest. I head up all of our customer engineering and product-led growth here, which means I get to do stuff like this, teach people about our platform, help them learn cloud native geospatial and things like that. Been doing that pretty much my whole career. So that's kind of all the different things that I do here at Wherobots. So hi, May.
Yeah, my name is Jaime Sanchez. I lead our partnerships team here at Felt. My background in computer science and geography. I've been doing geo for over 10 years and I actually worked with Matt previously. So it's not the first time we're doing a joint webinar and it won't be the last. So very excited to share about the partnership that we have today and the demo that's coming up too. So I'll move over to the agenda and give you a brief overview of what's going to be on today's table. And so for intro and market overview, we'll hear from Matt around how we're seeing geo evolve with AI today. Then we'll have an overview of Wherobots, an overview of Felt, a demo. We'll end with a about the partnership and then architecture, and then we'll have like 10 to 15 minutes of Q&A at the end, time permitting.
Yeah. And we just got the results of the first poll here. So it looks like question was kind of like the biggest hurdle preventing your spatial data from being AI ready. It looks like one of the top ones was like lack of structure and data not being ready for LLMs or AI models. Some different data silos, so being trapped in different legacy GIS or fragmented buckets, and then followed by kind of compute bottlenecks or then human in loop results. So I think everyone should be able to see those now on the screen. So
Yeah.
I'll kick off a few more of these as we go through. But yeah, thanks everyone for participating. So one of the big things I think we're starting to see as a change is really data and AI starting to have a need to exist in the physical world. So if we look at like from the first wave of like a lot of technology pre 2020 or stuff like that, there was a lot of like big focus on creating tools for people to capture data and like intent. That could be things like purchases. There was all the social media wave, everything around recommendation systems and data science. If you think about all the work that goes into recommending things on social media or your Netflix or anything like that, so much of the digital world was focused in on those innovations, right? There certainly was an a lot of technology changes within the geospatial space, things from web mapping and stuff like this. But the data infrastructure, if we're really focusing in on that, a lot of it was around those different things, analyzing lots of machine generated data to create insights that gave you something back, right? A recommendation system, A/B testing, all this different stuff. What we're starting to see now is that as things are changing constantly in the physical world, and you'll see this happening in so many different places. If I just saw, like a robot delivery service going down a sidewalk the other day, things like that. If you understand, how, things are moving and from, transportation services, like, of course, your Ubers or your logistics or your delivery, all these different things are kind of changing. And then more and more, how products and things in the real world are actually getting to people. I think we're at a time now and like a critical shift is when we need to understand that data in the same way we understood kind of the vast amounts of intent based data that happened in the past. And so we're at this tipping point where all these things are starting to come forward and shift into the physical world. Now, as we go forward here, um, there's certainly a lot that I think, we need to do, right? There's a lot of spatial people out there that are doing a lot of great work, and a lot of you are included on this call. So, you're ready to do this stuff, but we're a very small portion of the wide talent in terms of all the things that get built in the digital space, right? When we say spatial software developers, that could be GIS analysts, that could be geospatial data engineers, spatial data scientists, location intelligence experts, whatever that is, whatever you kind of call yourself, we're a really small portion. And when you think of like this, we used to always say like, well, spatial data is 80% of all this data, that number is like even bigger, it's like a bigger gap here between all the people building technology. So there's this huge gap in terms of number one, the technology was aligned to have different incentives and different outcomes. Number two is that there's this much smaller group of us that really know how to do these things, but the demand is going to increase greatly. So where does that get met? Is it going to be in terms of new technologies that is going to expose this to everyone else, or are spatial experts going to bring this forward? So that's kind of this general tipping point we're at here. Um, Jaime, if you want to advance to the next one. I think the other component here is around infrastructure and systems that were set up to do this. A lot of the geospatial, infrastructure that has existed up to this date was really serving a different kind of paradigm, right? And when I say that is that a lot of it was meant for um, places in the public sector and the government that have their own servers. The data was meant to be more long-term focused, like annual sort of reviews and stuff like that. If we're thinking about the systems I described before, they're collecting data every second, every intent and every click and everything like that. That's the scale that we're starting to see data come through at, be that from connected devices, be that from cars and things like that, or the logistics, or even through to satellite images and stuff like that. This compute infrastructure and the data infrastructure that was set up for GIS traditionally was really meant for these long-term static snapshots, big, wide-ranging, long-term change analysis. Whereas now we need insights that are getting updated on a regular, frequent basis. Those two things don't fit together, right? Modern cloud engines are geo incomplete. The geospatial support it varies quite a bit across a lot of these modern data infrastructures. When I'm talking about things like not databases, but things like data warehouses, visualization systems, processing, compute engines. There's a lack of support for the really core functions. Yes, you can do spatial joins and some big analytical questions, but what you want to be asking is what's happening now? How can I make that updated? And how can I get that moving through frequently at a scalable, efficient rate that's not going to be something that I have to hover over and maintain. And that's really what we're doing that. The final bit, of course, is that the LLM and code systems aren't ready yet for spatial, right? They're lacking spatial data. They don't have the context. They even just passing a geometry as well-known text can totally throw off an LLM. So there's all these weird things that are happening that just aren't ready for that. So how do we kind of fix this? That's the next big question we sort of have to answer here. And I think that it's really understanding the developer platform for the physical world, right? This is sort of where the partnership between Wherobots and Felt is really focusing on. How do we create a complete solution that's going to, help talent and and that understand spatial data really well, excel and match the pace of development within the rest of the sort of developer ecosystem that I showed you on that slide with all the dots, right? So these are the big things we're really focused in on, is that there's a few different kind of corners to this, right? Wherobots DB, which is giving you a complete set of spatial functions, right? We're really focused in on having that as detailed and as expansive as possible. It's not just ST as WKB or ST from GeoJSON. It's getting all the way into the nuts and bolts of stuff that really make things work, from raster, vector, array-based data, all these different formats. Another big component is the wealth of raster data out there. Raster data and things like NetCDFs and all this different stuff are really focused in on being able to work within a non-analytical system. If you have access to a, high performance computing engine and can, chug a job through and do all these different things, it's great. But that's not the work that the analytics throughput is demanding. So RasterFlow is our way to do that. That helps you bring well developed computer vision models, join raster data together, use that extensively and do that. And then the developer experience is to actually do that. So you can express the things that you want to do through common language, build that out, and have an AI that understands both the spatial functionality and spatial data. All these different things centered in one single platform is the goal of what we're trying to build here. Just going to launch another poll here as we go forward. So just kick that one off for sort of parts of the spatial stack that you're really interested in going forward. So Jaime, if you want to go to the next slide.
Yeah, and I was going to say that for us, it's very exciting to have one engine where we can do just both vector and raster processing in one go, one SQL query, and you get all of that. And on top of that, you're getting ML, getting AI on top of that. And when analyzing just the landscape, it's been a very disparate set of workflows where you have to like use two different tools or maybe go on desktop and use QGIS to handle that raster. And for us, where we're like connecting the developer experience from Wherobots to more the business user or the GIS analyst from the Felt side, it's really useful to have one engine for all of that. And I know now that in this agentic world, it's also easier for one agent to just hit one endpoint for that instead of having to wrangle a bunch of different API keys and tools. So it's a very exciting development here. But yeah, I'll go
Yeah.
to the next slide.
Let's wrap up the poll here. It looks like there's a big push in terms of AI agentic workflows. It speeds things up. We're going to be showing some of these different pieces here and really going through that. And then, as it goes there, collaborative mapping and visualization, that's something we're really excited about and connecting some of the other underlying pieces here. So yeah, thanks for sharing the results. There's two more polls. So I'll see those pop up as we go through here. But yeah, thank you for taking the time. So Jaime, I'll kick it over to you.
Yeah. So as we traverse I think the usage pattern path of geospatial, and we go from trying to process large scale data sets with whereabouts and analyzing them with whereabouts, how we think of like the engagement layer or how folks use these analysis and present it and collaborate on it. This is where um, our um, our view of the market is. It's we're seeing that natural language is the default interface for data discovery, and time to insight is now expected in minutes and not days. But what's happening still is that it's still requiring a lot of specialist interpretation, especially for maps and geo, and still requires a lot of time to wait for this, and most of it is in terms of data wrangling and requests and getting in the queue to get to the GIS specialist. And so what we're asking here is like, how do we free up the geo users' time so that they can focus on the analysis and less and in the interpretation or the orchestration of this spatial, and less so on the admin tasks of like, hey, moving this data set from here to there, or doing a bulk update on a bunch of different maps. So what's that change going to look like in the future? It's what we're here to understand, and we call this also the AI expectation gap. And we've all gone, if you're here and you've done mapping and you try to create a map in Claude or in ChatGPT, and you're gonna see things like hallucinated responses, maybe unpredictable output, or the LLM trying to use some Python library that might not be able to crunch all the data sets and all the data that you want. And so these are the three kind of things, three examples of the AI expectation gap, where business are expecting, a fully fledged result on a map that's interactive, but sometimes cannot be delivered because of how things are and how context is not being shared with both your data and then your application layer. Um, and then the other thing that's key here is that typically systems that have existed for a while you know, have existed and have had a lot of tools and different ways to manage and to do GIS operations or do the different types of analysis. But one thing that they're lacking is this AI readiness world is things like cloud native data, the ability to have an API for everything. So I'm sure you've experienced, at some point Claude or ChatGPT using a Python library and it just working. And that's Claude, of course, or that's ChatGPT and that's the LLM, but it's also the design of the service, right? It's like if you build a really good API, then AI is going to be able to use it. And that's the difference also that we're seeing in the market. Those tools that are AI ready and those tools that are not here. And the next slide is just a bit of like introduction to Felt for those who are new and haven't seen Felt before. And Felt is a modern AI native GIS platform. And in essence, this is very simple. Our core value prop is to build maps and dashboards in seconds from any database, from any format. We make mapping multiplayer as well, and we'll show you that in a couple of minutes. Me and Matt will be in the same map working together, and being able to ask. things like map out wildfire risk and electric grid infrastructure in one prompt, and having the wires, everything wired so that it knows to look to whereabouts, it knows to look to felt and divide the task. That's really where the exciting stuff happens. And these are all things that are built for AI because we've built APIs for everything in the platform. And then we'll also show you in the demo the native connection that we have to Wherobots, so you can launch a connection to your Wherobots cluster and pull data from there as well. And at the core of Felt is Felt AI. And so you'll see how we'll be able to, self-service and simple analysis with natural language. One of the key things that we have at Felt as well is we use TP for tiling. So we were able to scale hundreds of millions of points in a map without a problem. You can access Felt maps and applications from any device, via a mobile, via an iPad, or a desk computer with a web browser. You can comment on features, again, making this very multiplayer and collaborative. Sometimes I compare it to like a Notion or a Figma, but for mapping as well. And all of that now with our focus on more of the governance and SSO and enterprise functionality that most large organizations require. And with that, no more slides, and let's jump into the demo, and we'll start from the data. And I think we before we do that, actually, we do have one more poll. Matt, I'll let you chime in on that, and then also I'll share my screen. I'll stop sharing my
Yeah.
screen so you share.
Yep. Yeah, I was just curious to hear like how you want to enable access with AI agents like within your organization. Like that it's a big question in terms of like how you want to, who has the skills to query and extract these insights, and then, kind of who do you want to be able to like give more access to and stuff like that. And I think that's going to be an interesting kind of component. But again, AI can handle and enable different skills across all levels of the workflow here. So I'll let that run for a minute, and I'm going to kind of quickly showcase some of the things you can do with these different pieces. So I'll share that here. The data that we'll be working with and kind of the demo that we built is building off of this. It's called the Microsoft GeoLife GPS trajectory dataset. This is like particularly tricky data to work with, and when we talk about like physical world data, it's not just polygons and points and doing joins like that. That's all good, but there's particularly hard data that we want to work with. And this is something that for me in my career, it's always like I want to find these hard use cases and make them really easy for people to use and stuff like this. So this was a data set. It was pulled together by Microsoft called the GeoLife project from in 2007 to 2011. And it's 178 users, and they have 17,000 some trajectories. There were, over 1 million kilometers, driven. And basically it's logging, a pretty dense representation every 1 to 5 seconds, or about 5 to 10 meters per GPS point. Now, the data, of course, is in a very weird format. It's in, it has a lot of data, latitude, longitude, has altitude, date, time, stuff like that. So it gives you all of this data. If you go really deep into that, you can see here lat long. It's going to give you some of the metrics on like the user track. I think this is some of the elevation data, and then a timestamp, like a precise timestamp. So all that is really good, right? And you can certainly plot the points easily. But what we really want to care about is getting accurate information, analytics, and measurement. And to do that, if we're driving, if we're going up and down, we need to understand the Z altitude, Z component of the data, which is the altitude, and then the time, because the time traveled between the lat long and the elevation is going to tell us something very specific in terms of measurement and speed and velocity and all this different stuff, which is what we care about if you're coming from a logistics use case or anything like that. So I'm just going to end the poll here as well, just to kind of share the results. You can see here that who has the skills, it's mostly GIS or specialized engineers. And then tied across that, there's broad access, some can self-serve, data scientists and Python, SQL Salvi developers, and then some of the data is dark and doesn't get queried at all. So thank you for that as well. I think we'll have one more pulling in here as well. But basically, how do we make data like this useful? There's a few different pieces we'll use across Wherobots, but basically the number one most important one is this function here. Should, if you've written SQL, spatial SQL before, it make point should be there, but that you probably used it as an XY for latitude and longitude, and you maybe use Z for elevation, and you maybe have used M, which is basically this element for time, right? But if we have a full timestamp here with lat long, elevation, and time, we can get very accurate measurements. So that's what we're going to do here. There's a few different notebooks we can do that with in a, kind of setup data engineering process. You can see here we're setting up in a bronze, silver, and gold analytics workflow. So we're basically taking the raw GPS data as CSVs here, which I've processed and combined from these, I think they're PLT files, into that. Load the data in. There's some basic exploration, seeing what's in the data, creating some tables and stuff like that. So I can create all these different views of the data, see what's in it, understand some of the different things there, do some basic visualization coverage as I'm exploring, and then write that out to GeoParquet. So in this first step, I've basically taken the data, copied it over, pulled it into GeoParquet. The next step really focuses on that. I'm making these 4D geometry points. I have all the different components and transformation, turning time into epoch seconds, stuff like that. Validate the geometry. You can see all the different pieces here. Does it have the Z geometry? Does it have the M coordinate? All these different pieces. And then I can do some trip segmentation to figure out all of these different pieces by the user, by the trip, and stuff like that, and then build out trajectories from here. This is the silver layer is really doing the heavy spatial processing. So there's a lot of different steps here. The most important part you need to know is that this is developed and I can build all of this using AI tools, right? A lot of this code is, I know what I want to do. I know I can use it, but I'm building this out using AI assisted development. There's a lot of different things here. I'm using our map matcher here to actually map those to individual segments. So it's not like something, you know what you want to do. You can give the context about the data. You can see it's collecting specific things like, the altitude -777 is an out of bounds coordinate. It's cleaning, it's filtering, it's getting all these things, like there's trajectories from very obvious plane trips and stuff like that. And then I'm creating a few different analytical layers here, which we'll see in the map, right? So I'm pulling in my silver data here. I'm creating a view for hex bin activity and density in these different bins just for visualization purposes. Trip summary statistics, that gives me very specific information about the trips, like how many total trips there, average duration, stuff like that. There's an exploratory view where I can go in and filter looking at the individual trip IDs, elevation profiles to see how for specific trips elevation change, subsampling points along the lines at equal intervals. 2 to 3D distance comparison. How does that compare for, an elevation range? Here's the straight line distance and here's the 3D distance. So you can get a sense of what that changes like and how that measurement is actually important when you're doing different measurements like this. DB scan to find, clusters of stop points, all this different stuff. How can we do all of this very quickly? And this is kind of like, this was an afternoon project to get from A to B and get all this together. The first step is enabling our MCP. So if you see here, I'm actually opening up our Wherobots MCP that allows me to look at data and understand the data that I have access to. That could be local data and things like that. And then what I can also do is actually have it create and build out notebooks for me. So what I'm doing here is actually building out some different notebooks. It's building out some different things. This is just an exploratory view that I had it do just before this started. But again, you can see all the different stuff. I can have it very quickly build out here to understand what's going on with data that's in my data hub or raw data that I have as files. So this gives me a very clear way. It's a spatially enabled AI to actually go out and build that. So again, a lot of interesting stuff happening here. We'll show you what that looks like and how to build that out. But again, it also doesn't stop there, and we can actually build that out from there. So this is my final data. You can see all the different data sets that I've built out here. Right? These are ready to be pulled into Felt. I have my different views, elevation profiles, analytical, exploratory, hotspot clusters, stop clusters, all of this stuff that I wanted to build out. Now I can go in and adjust these things. Like one spot I did was I adjusted the DB scan function to find some denser clusters or heavy clusters. So back here, I changed this from, just 10 to 200 and changed the epsilon and all this different stuff. So you can adjust this as it comes along. But again, I'm gotten so far just by building out and prompting that helped me quite a bit. The other piece is that maybe even before this, I wanted to actually collect other data about roads. So what I'm doing here in the background is actually running a RasterFlow workflow here, which is some of these GPS points are on roads that don't exist within the OSM road view, which is what I pulled in to do the map matching, which we'll see in a minute. So there may be new roads that are pulled in. There may be sidewalks that don't exist in that view. This is something that we're actually using for a lot of different use cases to actually figure out where there are roads. So we can use this model, tile2net, segment that. We can stitch together raster data here. It's using the NAPE input, which is the National Aerial Imagery Program. I think that's the correct way of that. But basically, I can build out this whole different um, notebook here to actually extract sidewalks from basically anywhere where I have data. This data is in the US, but I can quickly do that and extract that. And you can also go in and see here's some sample data we pulled in for some different records. So it should be here somewhere on the map. But basically, this is the output that I'll get. So I can create data if I don't have it, which is some of the data from RasterFlow, which is that other part I mentioned earlier. So I'm going to launch a quick pull here. Should be our last poll. So imagery about information about kind of raster data and stuff like that. But again, I can build these out, pull that data out. It's mosaicing, stitching, doing all the stuff I need to do there. So that's kind of the last piece. If you're interested in trying out the MCP, it's very easy to get set up. We have this here, and we also are just launching our VS Code connection, so we can actually start to do that and run jobs and run notebooks outside of the web interface within that. But again, once I have my data that's ready to go here, it's very easy just to go in and connect that into Felt, which is where I'm going to kind of bring this over to Jaime and stuff like that. So you can see we're both on the map right now looking at some of the different data here. It's very easy just to get connected. So if I go to all my sources, I just pass that in. I have all my different sources that are from my team here. And if I go in here, you can see these are some of the layers that I pulled in. I've run some different queries. I can pull in full tables. But again, it's basically there ready to pull in and put on the map and go from there. So with that, Jaime, I'll hand it back over to you. And yeah, we can kind of kick off the second part of the slides here.
Thank you. All right. Yeah, awesome. And thanks for putting all that data together because all I had to do was basically go in there and style it, make it beautiful and show the results. And the heavy crunching was done in Wherobots. And so one of the cool things, as you saw from the map, is that and Matt, if you want to come in here and hover around, is that we're like both of us are in the same map and we can start drawing and understanding patterns and adding annotations to things. So for example, if I want to, for example, highlight, hey, there's a lot of like a lot of congestion over here. What could be going on? I can highlight that and make sure I also tag map and say, hey, look at this, right? And that will basically notify Matt that there's congestion around this segment. One of the cool things that you're seeing too here is the performance. And so, Matt, I think there was over what, like 200,000 road segments that you pulled in from Wherobots for this. Is that correct?
Yeah, it's a lot of different data. So you can, as you see in these different areas, there's some that are very clearly on roads, or and it's getting specific to exits, and there's some that are very clearly in like pedestrian areas, which I highlighted here. But yeah,
Mhm.
it's small, it's long, it's all different types of stuff here. Yeah.
Cool. And then what I can kind of like start doing is navigating through all the different layers, adding, for example, spatial analysis on top of it. Maybe I want to do a quick buffer, find the centroid, do some dissolve, do some joining, and also add statistics, bar charts, histograms to what I'm seeing here on the screen. So, for example, if I wanted to segment the road segments by average speed, which is a field that Matt calculated. I can go in here, go to road segments, and let's see if I have average speed over here. And quickly that will create a histogram that can filter on my map, which should be pretty fast because it's vector tiled. Then I know that there's other data sets that Matt pulled in. For example, I'm going to hide the road segments layer and look at traffic jams. And this is interesting because from all the data that we got from all the GPS coordinates, they were map matched to streets. And then we also got hotspots on traffic jams. Um, and then I know that there's like a attribute here that Matt calculated, which is I think point count. And we can do the size depending on that, or maybe the color depending on that. And so that way we have, let's say, Jenks, so that we can say, hey, these are the most interesting traffic jams because there's the most wait time there for traffic, and I put them in red. So for example, this one would be a hotspot for traffic because there's 26 in there. Then there's another layer that Matt you brought that was interesting. It's the elevation profiles, and I think I filtered all of this down. But do you want to talk about how you're moving away from just X, Y, and then using elevation to find patterns here as well?
Yeah, the most important part here is like because we have all four fields, lat long, altitude, and time, we can take even snapshots. And basically, these are evenly spaced points, not based on lat long, but on all four of those variables. And then we can basically sample the elevation profile of each of these trips. So, because if you're going uphill, you might be going slower, or the distance might be further. You can see this track further out in the western part of the country, where basically there's mountains and elevation, and we can quickly kind of correlate that to see where there's higher elevation and these different mountainous regions or things like that. And you can see as some of these trips, even in the east, there's these changing elevation profiles and stuff like that. So it gives us a very clear view of like not just stoppage, and which in a dense urban area it might be flat or something like that, but we can figure those things out and get a very clear view of all of those different attributes. Again, like I knew what I wanted to do, but I didn't have to have the expertise of coding all of that just to get to this very quickly, right? That's kind of the cool part here. This is very cool stuff that we can pull out of it, but again, it's like we're getting a lot further so much faster with this, which is great.
Yeah, awesome. And so just to speak again around the connection and how we pull this data in. So I'm going to go to this layer which has all the traffic jams that were calculated. I'm going to click here on the layer here, and I'm going to go to data, and I can see, for example, this is something that's refreshed every day, but I could refresh it very easily every 15 minutes, for example. And another cool thing just happened. I think Matt filtered this thing and it filtered on mine, just
Yeah.
again to highlight the multiplayer aspect of it all.
Yeah, what's cool here is I can quickly just filter to say like, okay, where are the clusters with the most users or individual trips in them. And you can see here that it's very clear that there's a few spots here, but like this part of the city has very clear density of traffic jams. So there's something happening over here that we want to focus in on. And it gives us a very clear picture of that, which is cool. And I can just reset that and then everything goes back to normal.
Yeah, and if you want to change the query to maybe calculate something different to us, how we classify a traffic jam, here's the query going back in Wherobots SQL back to Wherobots. And again, this is something where we can pull in multiple layers, and it could be petabytes of information, and that's all handled smartly by Wherobots. And then the results are handled also smartly by Felt. Um, and then another cool thing that I was gonna show here is like as we wanna like tell the story here, there's different points where we add AI as well on our end, which is like if you wanted to like ask a question about the data and maybe shape it differently, there's an AI assistant here that will help you do that. And then also one of my favorites, it's really simple, but it's a way to kind of like also do that for pop-ups or for adding JavaScript to the map. And so let's do a simple one here where we add a custom pop-up to explain the traffic jams. So I'm going to go here and select stop points, and it's going to enter a kind of like a code editor window where I can add some flair to this. And I want to say, hey, maybe restyle this in the scene of a classic arcade game, just using one of the prompts that come just to style it so that maybe someone that's coming in understands what's going on with these traffic jams and why they're important. I could do an animation. I could enter any HTML I want it here, and it will basically show you. And so I see here that I'm gonna maybe just add some width to this, so that you can see it. And now you have a really cool futuristic view into traffic jam data. You even recognize that it was traffic, so he added some like lights there. And so if I hit save now, every point has that. Um, and then another thing that I wanted to show you as well is if you wanted to customize how interactivity happens in the map, there's also a possibility for that. So If you go to custom extension, then you can like have a JavaScript code editor where you can just paste in or write in your own JavaScript, or you can add your own prompt. I'll take one of these just for the sake of simplicity, but in this one, I'm adding a button that does an action. And often what we hear when we talk to people that are developing applications is, yeah, there's all these like mapping libraries out there, but they take time to get to know. What if there was that mapping library connected to an AI assistant and that gets the interactivity part done. And so this takes me to a random city. And as I click, you can see how it's moving around in the world. It took me to Moscow, and here it took me to Stockholm. And then I can hit save, and that once I'm done here, that becomes part of the map, and it's a button that I can use. I also prepared another one, which is trip data that I also got from Matt. I'll show you the table here. It has timestamps. So it has the user ID, the trip ID, the start, and then geometry. And then one custom extension that I was able to build here is basically one that animates the trip by day. So I'm gonna hit play over here, and it should animate, the trips per day as they pass. And you can see on the left the different prompts I did. The first one was like, hey, can you animate the trips player by date? And then it had some errors, which is fine because we're able to feed those errors back to the AI assistant, and it'll eventually fix them. And you can see how you can also customize the speed and other things. And you can really, the sky's the limit. You can include external API calls in here. You can include some other libraries that you want to use in your map. And the beautiful thing is that it's all hosted in the same map, and you can share it and deploy it, as fast as you built it. Then I was going to show you another point of interaction here, which is what I talked before, which is, hey, we live in a world where now agents need to be able to do this work as well. They need to be able to create a map. They need to be able to go to Wherobots and use their MCP. And so here I have my code studio. I use Hero, and basically I have my working directory. And in one of the questions I asked before, it was like, hey, build me a map of restaurants in Beijing using the Wherobots connector. And so it knows to use the MCP, and it was able to also use Felt skills to basically go in and use Felt Python, which is our Python library, to build a map. And here it produced a URL that I can click on and show you the results. It typically takes 2 to 3 minutes to build a map like this. But here you see it pulled all the Foursquare data from Wherobots. And the beautiful thing is, again, it didn't like download the data. It just did the connection, and Wherobots and Felt handled the integration there. So you can see the query that the AI built and queried and built into the map. Um, and yeah, that's been a little bit around how we expect the future to be. So, of course, you're going to have workflows that start in a map and end in a map, but we also are going to have workflows that start in a terminal or in a chat in a chat box, and then takes you to the map. So you to the finishing touches, maybe to like style and add more widgets and search and things like that are things that are more visual. With that, I'm going to go back to the presentation over here and talk a little bit about the partnership and the architecture. So we have in this space seen a lot of like, as Matt put it, a lot of geospatial advance in the data platforms, right? They're supporting more and more geospatial, but one of the things that still lacks and is still not there is a engine that's just for geospatial, and that's what from the Felt standpoint, it's what we see is a place where you can do both your raster, both your vector, and add some more of like the advances that they're doing in AI for like RasterFlow for that. Add it all in one place so that you can query it in a very simple and unified way. And so when you look at the things that you can do with both tools, On the left, you have, your data engineers, your GIS developers, your data scientists. They want to process and analyze large amounts of geodata. And on the right, you have the need to build applications, build the engagement layer, build dashboards, collaboration tools to really make that data processing shine and actually, convince whoever stakeholders you're trying to convince to do the thing that you need to do. And so with that, we have like a complete stack, right, from the bottom up. And I'll let Matt chime in as well on this, as he also always talks about the modern data stack.
Yeah, I mean the reason I always talk about the data layer is like I feel like so many times like a lot of there's if you see like a cool GIS application or web app or whatever that is, like there's that feels like this nice presentable layer, and then the back end it feels like you're behind the sheet in the Wizard of Oz where you're like pulling things together. I got some Python here, I got some SQL here, I got some this thing, and maybe the whole thing works once, but and it has a beautiful result. But how do you do that repeatably? You need like a lot of stuff built in to kind of manage that. And it's all these different pieces here. You need data and storage integrations at the bottom layer. That data has to be structured and efficient, right? There's if you know anything about spatial data, it's like there's a million different formats. Like the cool part about the AI piece is that I can quickly say if I have a grib2 file or I have some strange format, I can quickly read that in, understand where it is, set up the process, download it, and then quickly convert that into a cloud native format. And then with Wherobots, with our platform, there's storage built in. You can bring your own storage, whatever that is. So you're quickly jumping into these cloud native formats. You have the data management and collaboration built in, the catalogs. Basically, it's the most efficient way to you're basically storing your data in these cloud native formats, and you have a light metadata layer to read this in, and that's all you need to connect it into to Felt. Whereabouts DB has all the functions and different pieces. We have the scalable pieces to bring that there, and we can serve that up through the AI features and the different pieces here. So it gives you all this full stack to do the data infrastructure work and bring that up to scale very, very quickly, including with RasterFlow. You can generate PM tiles, all these different things. The other parts that we bring in is like when you connect that to Felt is you also get the skill of like an operational database. You get location data services, all these different pieces, the cartography, the rendering, and then all the ability to build the applications. We're not just talking about like dashboards, but there's different views. You could have an executive dashboard view. You could have a very, tactical dashboard view where you're clicking and adding notes and commenting and things like that. It's responsive. You don't have to worry about the data updating because there's jobs running in Wherobots, and then there's maps that are kind of reading that in. And then you have all these collaboration pieces. You can build mobile apps to go out on the road. So you get this full, complete view of everything you need from the really heavy data engineering and data construction and pieces like that. You get the AI built in to help you accelerate that and go much faster. And then you can bring this all forward to a complete platform that helps people really interact with and understand the data. So it gives you all from the very bottom basic levels all the way to the top this complete stack that can build that out, which is really the key here. So it's kind of exciting to see all of that happen because again I built this project out from an idea to building and sharing a map with Jaime, and then he took it further. As you just saw right now, like probably total time for something like this is like a handful of hours, like an afternoon you can get there and do this different stuff, which is really, really, really exciting.
Yeah, no, and we can go back and forth. I think you added a widget when I was working on this other thing on the same map, and that just removes a lot of friction. And yeah, as you go up from the bottom, which is a data storage, all the way to the up to the top, one of the things that I love is that then everyone in the organization can interact with geospatial however they're comfortable with. Like Felt, maybe it's a easier way to kind of like get started, but with wearables, you got all this processing power for really doing amazing things. So combined, you really cover all the bases that you might need in a modern geospatial organization. And
Yeah.
with that, I think we can maybe open to some questions.
Yeah.
Matt, what do you think?
Yeah, I see a few here. Like, when should we use whereabouts data versus felt? How are they different? If you kind of look at it, they're kind of fit together in this nice like triangular piece where Wherobots starts at the bottom from the data side and builds all the way up, and then Felt comes in and handles some of those data pieces, but it's the integration and connection there where they just kind of fit together. So we're really focused in on making spatial data fast, cheap, and accessible. Like I think there's close to 36 million points here of data. The whole thing, like I said, it's very fast to run. I don't need to worry about infrastructure. I don't need to worry about all that different pieces. And then I'm just a SQL query away from putting this on a map. That's the whole piece here. You don't have to wrestle with your infrastructure or anything like that. And I can do that very quickly.
And
Um,
I can add to that and say that also, like, if you go down to the actually where it's stored, one of the beautiful things is separation of storage and compute, and how we use S3 or any bucketing system to store the data at rest and really only like use the engine once we need to look at it. And that makes it really powerful because you are not spending all this money on an always on database. So that's another way to look at it as well. It's like, hey, yeah, you have your lake house in Wherobots or as a source of truth using things like Iceberg in S3, and then you're able to pull that data to any type of application like Felt.
Yep, exactly. And then that's the big component. Someone asked where the data would be stored. If you sign up for a Whereabouts Pro account, it's basically comes with its own S3 storage built in, so it all lives there. You can bring your own if you already have that and connect that in. But one thing we heard from people is like, I just want everything ready out of the box. It comes with the storage, it comes with the catalog, comes with the processing, and then with Felt, you add in all the visualization, connectivity, and shareability that you get. So you get that full, complete end-to-end piece from there. How should GIS data be structured and visualized in spatial analytics and Whereabouts and Felt? So you can with if you wanted to like the best way is to use the cloud native formats, your GeoParquet, cloud optimized GeoTIFFs, PM tiles, stuff like that. That said, we know that most data is not in that format, but with the MCP, I can basically tell it, hey, I have files in these formats, help me write it so that I can read those in and do that. And the MCP can handle nearly all of that development and then can build out the correct data engineering structure to say like start with a bronze layer, then move it into silver to do the heavy spatial processing, the final layer do the analytical processing so it's ready to serve up and serve from that perspective. And it handles that full process for me because it knows all the functions that we have access to and things like that. So again, the AI can help you just get over that hurdle a lot faster and get to what you need to do there. um, can you handle 3D tiles and point clouds? So again, kind of what I said before is like we want data in those cloud native formats so it can be queried and pulled in. So if you have point clouds, it can read those in, do the transformations, and bring those in. And if it's tiles, if it's pure visualization, that's another piece where I felt like one of the things I love about it, and I may correct me wrong, is like you can kind of just add whatever you wanted to the map, which is like a really freeing thing. So if you have tiles or visualization or pre-computed tiles, like at that very top layer, you can add the visualization and pieces like that very, very quickly. So you can just basically, bring those in. So point clouds on the data layer, you can roll those in, help bring them into cloud native formats, do your processing, all those different pieces there and stuff like that. What are the differences between the bronze, silver, and gold levels? So this is a pretty dense question, but to give you a high level at a very just a simple, it's a data engineering process that says at the bronze level, from your source format, whatever that is, we want to get it into a cloud native format. So it's a apples to apples. If you have data here, it looks like this. It's now in the Wherobots DB, ready to be ingested there. Silver layer is where you have your heavy spatial processing. So that's where you're doing your spatial joins or your 4D kind of transformations or map matching, all those different pieces. That's in that middle layer. And then in the in the gold layer, you want it to be as efficient as possible so that any upstream system like Felt can just connect to it, query it, put it on the map, and have it as fast as possible. The nice thing is that I can do and use different compute scales in each of those layers to really scale that up. So that's the very simple explanation there. Let's see here. Who's your target user for Wherobots plus Felt? Jaime, do you want to answer that one?
Yeah, I can't see the questions. Can you repeat it, please?
Yeah, who is a target user for Wherobots plus Felt?
Yeah, so I think that's a great question. So we have a set of industries that we see a lot of success in together. But the users are folks that have a ton of geospatial data, and you're coming into whereabouts because you can handle raster, you can handle large amounts of vector data. and you're a data engineer or a data scientist doing your work in Python, in Spark, in Sedona and Wherobots. And then the other end is you're a business user and a GIS professional or a web developer. And we target really the different personas, and this is why it's great. Really depends on kind of like the use case. And then if you want to be able to crunch tons of data and you're in Felt, like we're talking about petabytes of information, then now you have a UI to go and tackle that. You also have the MCP server if you're more technical, but you can now have a UI to be able to crunch large amounts of data. So we have it here on the slide. It's really for everyone in the organization that has anything to do with geospatial.
Yep. There's a few other questions here. Is Whereabouts only available on AWS or can it be deployed on any cloud platform? So it's available on AWS for our Pro, but then we also have some options for BYOC. So if you want to reach out about those, definitely get in touch with our team. This one's for you, Jaime. What are the options for exporting maps as different formats? Does Felt have a layout editor that you can build as well?
Yeah, you can export to PNG and to PDF, and there is a lot of settings that you can do in a felt map to be able to arrange and the extent of the map and how it gets exported, and you can think of it as a replacement for ArcGIS in that sense. The other thing that we see a lot is just folks wanting to you also mentioned QGIS in the question, and so we have a plugin for QGIS, meaning and I have it highlighted over here in the slide, meaning that you can, if you want to customize fully or even more, you can pull all the layers from a felt map into QGIS and back and forth. And that way you can really have control of how you print out or view the data.
Yeah. Um, so in terms of what can organizations expect to pay to have access to the same functionality, reach out to our teams. It definitely varies by like data volume and scale. Like for the, for Whereabouts, there's different ways you can kind of go pay as you go, or there's like our Whereabouts Pro, you can kind of sign up and get access to like a lot of the functionality out of the box for a monthly cost. So those are the different pieces. And then Jaime, I think you guys have all that information listed on your website, correct?
Yeah, we have our pricing on our website, and then you can also reach out to our team for further information as well.
Yep. Lots of questions coming in. Is the MCP server required to integrate spatial analytics and Whereabouts and Felt? So it's not required. It comes with the platform, it comes with Whereabouts. Like you have AI, Felt has AI features baked in. We have the MCP server and the AI features baked in, so it comes with it. But the connection's there. If you want to write your own SQL and your own code and everything like that, that's totally fine. You can definitely do that as well. But again, I can write a lot, but it just helps me speed things up and do it so much faster. So I end up using it anyways. So that's quite a bit what I do there. Can you handle 3D visualizations, including things like mesh, Gaussian splat, stuff like that? Jaime, I'll ask you about that one.
Yeah, we don't. That's on the roadmap though. We can't do 3D visualizations yet, but it's definitely in the roadmap for this year.
Yeah,
So stay tuned.
cool. Cool. I think we got to the all the questions. I'm tracking them across the chat and everything like that. So I think we got all of those. Yeah, thank you. Yeah, there's one last one. We do raster transformations as well across some of the. There we have raster functions and Whereabouts DB as well as raster flows. So yeah, thank you everyone for taking the time today. We're really excited to showcase these different pieces together. The best place to get started, you can go ahead and sign up. So from the Whereabouts side, we have the Whereabouts Pro. You can sign up for the trial account. You get a certain amount of 30 days and free credits for that trial. That gives you full access to the platform. You can do all the things we saw today, and you can get started there. And then Jaime, how can they get started with Felt?
Yeah, you can also go sign up for a free trial. I think it's a 14-day trial where you can experience all the functionality as well. And then if you get in touch with our team and need more time, you can also do that as well.
Yep. And anytime reach out to us, we're happy. We work together all the time, so we're happy to help you bring both these pieces together. So just mention that you were on our webinar, you want to work with Whereabouts and Felt together, and we will help you do that. So thank you, everyone. Big group here today, so it's exciting to talk to everybody. And yeah, we're looking forward to talking to more of you. So with that, we'll wrap up today, and hope to hear from more of you in the future.
All right. Thank you, everyone. Thank you, Matt. See you.
Thanks. Take care.